Hi, I'm Mark from Hungary, and really quick, I just wanted to tell you that this video would look amazing if it was animated like a TED riddle video. But since I can make animations like that, there will be no animation in this video. But if you feel the content worthy and you have the required skills, feel free to animate and maybe mention me in your video. But now, let's get to the topic. So, imagine that you're a spy. One day your boss asks you to send a sequence of whole numbers to your friend, using only a typewriter. But there's a problem. On the typewriter there are only numbers, only the integers from 0 to 9. No space, no symbols, no other characters like letters, just the numbers. And there's another problem. You know that the enemy can capture any message. So you have to code it, making it as hard to decode as possible, using the least amount of different digits possible. You can call your friend and tell him how to decode your message, but you can't tell him what the numbers in the sequence are, because there are too many of them. So, how do you code it? Pause the video if you would like to think, and continue watching if you have the solution or you want some hints. When I heard about this problem a couple of years ago from a friend of mine, it immediately aroused my curiosity because it's so easy to understand yet really hard to figure out. And I knew that my friend is a really smart guy, so the solution must be difficult. But it's the purpose of this video, to improve your way of thinking. So maybe you will come across with really easy problems and you think that they must be difficult because it's supposed to be difficult, and you don't even start looking for easy solutions. You write down long equations that lead to nowhere and you're stuck. And the purpose of this video is to remind you that not all the hard problems have a hard solution. So for example, this problem has a really easy and nice solution. But back then, I didn't figure it out because I thought that it must be something really hard. And I didn't even think that it has a nice and easy answer. But now, let's get back to the story. So my friend told me this problem, and the first solution I came up with is to put 3 zeros between the numbers as a space. And I think it's a pretty common solution. So you write down a number and then you put 3 zeros after it, and then you write down the other number in the sequence. And it works, doesn't it? Well, not really, because for example, if 10,006 is among the numbers, it's 1006, and your friend will think that the 3 zeros between the 1 and the 6 is a space. So yeah, this doesn't really work, and in fact, no matter how many zeros you put between the numbers or what numbers you use instead of a space, it won't work because you can't replace a space with numbers, because those numbers could occur in the sequence among the numbers. So I started thinking again, how on earth could I possibly write down numbers using less digits? And then something popped up. Number systems. Really quick, if you don't know what number systems are, they are basically different methods to write down numbers. So, for example, the base 10 number system that we use today works like this.
Hey, future Mark here to explain how number systems work. So basically, if you want to write down a number, let's say A, B, C, D, in base X number system, this means this number is in base X number system, then this number equals to X to the 0 times D plus X to the first times C plus X to the second times B plus X cubed times A in base 10 number system. So let's see an example. If we wanted to write down in base 10 number system 7513, we would write down this number in base 10 number system like this, and this number means it's 3 times 10 to the zeroth power plus 1 times 10 to the first power plus 5 times 10 to the second power plus 7 times 10 to the third power, and this equals to 7 times 10 to the third power is 7000. 5 times 10 to the second power is 500. 1 times 10 to the first power is 10. And 3 times 10 to the zeroth power is just 3. So basically this is how every number system works. And I should also point out that every number system has just as many digits as the bases. So for example, a base x number system has x different digits. The base 10 number system, what we all use today, has 10 different digits from 0 to 9. But the base 8 number system, for example, it doesn't have a digit 8 or a digit 9 in it, so it only has 8 different digits.
So, what do we have to do now? Well, we have to find the number system with the smallest base, because that includes the smallest amount of different digits, and then use that number system. Which is that? That's the binary or base 2 number system. And how does it work? Well,
so how base 2 number system works? In base 2, remember, we only have 2 digits, zeros and ones. And you can write down any number with these 2 digits in base 2 number system. For example, if you wanted to write down 5 in base 2, then let's write 5 as the sum of powers of 2. For example, 5 equals to 4 plus 1, which is 2 squared plus 2 to the zeroth power. So in binary or base 2 number system, this will mean 101. So let's see another example. If we wanted to write down 73 in base 2, 73 equals to 64 plus 8 plus 1, which is 64 is 2 to the 6th power, 8 is 2 cubed, and 1 is 2 to the 0th power. So this number in base 2 will be 1001, 001.
so what you have to do now? You should write down every number in the sequence in binary number system, and then put another digit between the numbers as space, for example a 2. Because if you tell your friend that whenever he sees a 2, that's a space, he will know exactly where the spaces are, because in binary number system 2 doesn't occur, so he won't confuse it with the digits.
So how do we code our message? Well, let's suppose that our sequence of numbers starts like 1, 3, 8. Then first we have to write down 1 in binary number system, which will be 1. Then put a space after it, which will be a 2. Then write down 3 in binary number system, which is 1, 1. Then another 2 as a space. Then write down 8 in base 2 number system, which is 1, 0, 0, 0. Then another space. And we can write down all the numbers in the sequence in base 2 number system, so we can write our code. And when our friend will look at this code, he will immediately spot the 2's as the spaces, and he will know that the numbers between the 2's are the numbers coded in binary number system.
So, you've just done it. You made it. You did it only using 3 different digits. You are proud, you go home, you have a sleep, and then the next day you go to your office with a smile on your face. But your boss is in the office and he doesn't have a smile on his face. He's shouting at you and he is really angry. He said that the enemy has captured the message and they figured out how to decode it. So now you must do it using only 2 different digits. You're terrified because you know that you can't use the same strategy with only 2 different digits, because you don't have a base 1 number system it's because 1 to the first equals 1 to the zeros equals 1 to the second, or 1 to the any power. So you can't use the same number system strategy to write down all the numbers in the sequence in binary. So what do? Pause the video if you like to figure it out for yourself, and continue watching if you want some hints or you have the solution. The solution you come up with is brilliant yet powerful. It's really easy solution, but it's really hard to figure out, at least if you think of this problem as a really hard problem, as a difficult one, then you won't figure it out. But if you don't consider it as a difficult problem and you want to find some shortcuts or easier solutions, then you will probably find this answer. So all you have to do to write down all the numbers in the sequence using only 2 different digits is write down as much ones as the numbers are and put a 0 between them.
So, let's suppose that your sequence starts like 1, 3, 8 again. Then you will have to write down 1 once, which is 1, then a 0, then 3 ones, then a 0 as a space again, then 8 ones, then a 0, and so on and so on. And it's just this simple. Your friend will look at this sequence of ones and zeros, he will immediately spot the zeros as the spaces, and he only has to count the ones between the zeros, and he will know what the numbers in the sequence are.
And it really is a really easy answer, but I've asked a lot of really good math students before about this riddle, and maybe 1 or 2 of them figured out this particular solution. But now you've managed to do this. You coded the sequence of numbers using only 2 different digits. It isn't possible with 1 different digit, so you're proud of yourself. You go home, you have a sleep, and next day you go to your office with a smile on your face. But your boss is in the office too, and he doesn't have a smile on his face. He's throwing things at your direction. He's shouting, he's yelling, and he's so furious. His eyes are blazing, and he says that the enemy has captured your message again. And you have to code it using only 1 digit. And now you're really terrified because it is impossible to write down all the numbers in the sequence using only 1 digit, because you wouldn't be able to put a space between them because you don't have different digits. But yet it is possible. So pause the video if you would like to figure it out for yourself, and continue watching if you want some hints. Here's a hint. Your code the previous day was a long series of ones and zeros. Doesn't that ring a bell? It should. Yes, it is binary number system. Your code yesterday was a number, a huge number in base 2 number system. So what you have to do now is to find the value of that number and write down as many ones as that number is.
So let's say that today your whole sequence is 1, 3, and 8, because it's easier to deal with a shorter sequence than with a really long sequence. So the previous day you would have written down this number 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, and not a 0 after it, because after 8 there will be nothing now. And this number in base 2 or binary number system equals to 12,031. So now you have to write down 12,031 zeros, and your friend will count the zeros. He will know that it's 12,031 zeros that you have written down for him, and he will convert 12,031 in binary. Then after he got this number, he will use the strategy that he used the previous day.
How does he count the ones? well, that's not your problem. So, you figured out the solution. This is really the best solution, and I'm not joking now. You've written down all the numbers in the sequence using only one different digit. Well done. You can go home, relax, and the next day your boss will probably promote you. Of course, there are more difficult answers for this problem which are more beautiful. For example, here's my personal favorite.
Okay, so for the sake of simplicity, let's say that our sequence today is 1, 3 and 8 again. So on the second day, you would have written down 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, 8 ones. And now what you have to do is to count how many digits are there in this number. So there are 14 digits in this number. Now write down the first 14 prime numbers, which are 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on and so on. I won't write down all of them, but you can write down the first 14 prime numbers. Then raise all the prime numbers to the power of 1 or 0, depending on which position those numbers take in this sequence. So, for example, you will raise 2 to the first power because in the number that you have written down, the first number is a 1. Then you will raise 3 to the zeroth power because the second number is a 0. Then 5, 7 and 11 to the first power because then the 3 digits in this number, these are all ones. Then you will raise 13 to the zeroth power, then the next 8 numbers to the first power. Then multiply these primes together and you will get a huge number. And if you get that huge number, that write down as many zeros as that number is. And your friend will count how many zeros you wrote down for him. Then, what the number of zeros are in your message, he will count the zeros, he will do the prime factoring of that number, and when he did it, he will see this sequence if he writes down all the numbers and write down that which power is every prime on that sequence is on. And he will see that 2 is on the first power, 3 is on the zeroth power, 5 is on the first power, just as 7 and 11, and so on and so on. And he will write down the powers next to each other, like this, and he will get the exact same sequence as he would have got the previous day, and he will apply the same strategy as on the second day.
So this was my personal favorite solution, and I think I figured this out for myself after my friend told me how to figure out another solution, the one that I showed you before. And basically you can get and you can create infinite amount of different solutions, and you can create as hard solutions as you want, as difficult to crack as you want. It worth a couple of minutes to think about this and to figure out and come up with other solutions. So our video has come to an end. I hope you enjoyed it, and I hope you understood what I was trying to say, and goodbye, and again, thanks for watching.